Welcome to Vidya Myriad. This video is made for class 9 on chapter number 8 Quadrilaterals, and today we are going to do exercise 8.2. So to begin with this exercise, you must first understand the midpoint theorem and the converse of midpoint theorem. The concept video has already been uploaded, and I will also provide the I button link. You may go through that, understand first how to apply, and then come to the exercise. So to begin with the exercise, question number 1, there is ABCD quadrilateral in which PQRS are the midpoints of the sides AB, BC, CD and DA. AC is given as a diagonal. Now let us prove the first point. You have to say that SR is parallel to AC and SR is half of AC. We will just simply follow the midpoint theorem here. In triangle ACD, just write S and R are the midpoints on AD and CD. So we can say that SR is half of AC and SR will be parallel to AC as per the midpoint theorem. And let us consider it as equation number 1. In triangle ABC, P and Q are the midpoints on AB and BC. So PQ is half of AC and PQ is parallel of AC as per the midpoint theorem, that is equation number 2. Now from the equation number 1 and 2 we get PQ is equal to SR and PQ is parallel to SR. When one of the sides are equal and parallel, we can say that PQRS is a parallelogram. Question number 2. ABCD is the rhombus and PQRS are the midpoints on the sides AB, BC, CD and DA respectively. Show that the quadrilateral form PQRS is a rectangle. So to prove this, we will use the midpoint theorem. So let's begin with the triangle DBC. In that triangle DBC, you can see that P and Q are the midpoints on DC and BC. So we can say that PQ is half of BD and PQ is parallel of BD. Using the midpoint theorem, we can quote it as equation number 1. Same way, let's take the opposite triangle now, ABD. In that case, S and R are the midpoints on the respective sides. So we can say that SR is parallel to BD and SR is half of BD. Let it be equation number 2 as per the midpoint theorem. Considering both the equation 1 and 2, if you see BD is common in between, we can say that PQ is equal to SR and PQ will be parallel to SR, and thus PQRS is a parallelogram. Now we are told that ABCD is a rhombus. It's already given to us. So if I consider the line AB and BC, we have half of AB and half of BC will be equal to them. That means RB will be equal to BQ, which means angle 1 is equal to angle 2 as per the isosceles property. If the sides are equal, their respective angles are also equal as per the isosceles property. Now consider the triangle ARS and triangle CQP. The below diagram, if you see the yellow lines, opposite triangles are there. Let us try to make them congruent. Now in that case, we have done AR is equal to CP and AS is equal to CQ, because we know that PQRS are the midpoints. SR is equal to PQ. We have just proved above that PQRS is a parallelogram. So the triangles are congruent by SSS criteria, and with that we can say that angle 3 is equal to angle 4 by CPCT. Now consider the line AB and consider the line BC, considering only R angles and Q angles. Now if you see, your R is made up of angle 1 plus R plus 3, which is equal to 180 degrees. And if I consider Q, it is made up of angle 2 plus Q plus 4 is equal to 180 degrees. Comparing both the equations, we will get angle 1 plus R plus 3 is equal to angle 2 plus Q plus 4. But we already know that angle 1 is equal to angle 2 and angle 3 is equal to angle 4. So we can say that angle R is also equal to angle Q. So once we know that PQRS is a parallelogram, and we have also come to know angle R is equal to angle Q, but according to the parallelogram, SP is parallel to RQ and PQ is transversal, we can say that angle R plus angle Q is equal to 180 degrees. They are forming the co-interior angles. So that means each angle is 90 degree. and in forming a rectangle, one angle proved 90 degree will be proved. So we can say that PQRS is a rectangle. Question number 3. ABCD is a rectangle and PQRS are the midpoints on the sides. Show that quadrilateral PQRS is a rhombus. Now let us prove this. Let us consider the triangle ABC. In that case, RQ is half of AC and RQ is parallel to AC. Using midpoint theorem, let it be equation 1. Same way, take the opposite triangle now, ADC. S and P are the midpoints, so SP is half of AC and SP is also parallel to AC. Let it be equation number 2. From equation 1 and 2, we can say that RQ is equal to SP and RQ will be parallel to SP, and thus PQRS is a parallelogram. Now it is proved that it is a parallelogram. We need to prove that it is a rhombus. For that, we are going to take two adjacent triangles ARS and triangle BRQ. Now here we know, because it is a parallelogram, angle A will be equal to angle B, which is equal to 90 degrees, and AR is equal to BR, R is the midpoint, and AS will be equal to BQ because half of AD will be equal to half of BC. So by SAS criteria we can say triangles are congruent, and when triangles are congruent we can also say that RS will be equal to RQ. Similarly we can say all the other sides are also equal, and in the parallelogram, because we have proved PQRS is a parallelogram, opposite sides are also equal, so adjacent sides are also equal. So we can say that since all the sides are equal and it is a parallelogram, PQRS is a rhombus. Question number 4. ABCD is a trapezium in which AB is parallel to DC, BD is a diagonal, and E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. Show that F is the midpoint. So let us mark G on EF where they are intersecting DB and EF, and let us consider the triangle DAB. In that we already know that E is the midpoint on AD, and we know that EG is parallel to AB. So using the converse of midpoint theorem, we can say that G is also the midpoint of BD. So in that case, another triangle if we take BCD or BDC, G is the midpoint which we have just said, and we know that GF will be parallel to DC. So that means F is also the midpoint of BC because of the converse of midpoint theorem. Question number 5. In a parallelogram ABCD, E and F are the midpoints of the sides AB and CD respectively, and show that the line segments AF and EC trisects the diagonal. Now let us first understand this. ABCD is a parallelogram, so the sides opposite will be equal, which means AB will be equal to CD and AB will be parallel to CD. It means that AE is parallel to FC also, because E and F are the points on AB and DC and they are the midpoints. And we know that AB is equal to DC, so definitely half of AB and half of DC will also be equal. So let us consider AE is equal to FC. Considering one side, opposite side equal and parallel, we can say that AECF is a parallelogram. Now take a triangle, that blue part which I have marked, DQC. In that case, you have F as a midpoint, already told to you, and you know that FP is parallel to CQ. So we can say that P is also the midpoint, and we can say that DP is equal to PQ using converse of midpoint theorem. Similarly, take triangle BAP. In this, E is the midpoint of AB and EQ. So therefore, we can say that Q is also the midpoint, and thus BQ is equal to PQ. And using this equation, all the three, we can come to know DP is equal to PQ is equal to BQ. We can say that AF, the line segment AF and EC trisects the diagonal BD. Question number 6. Show that the line segment joining the midpoints of the opposite sides of the quadrilateral bisect each other. Again, by midpoint theorem, let us make the first inner quadrilateral as a parallelogram. If we take the triangle ABC, P and Q are the midpoint, so we can say that PQ is parallel to AC and PQ is half of AC. And similarly, we can say if we take triangle ADC, SR will be half of AC and SR is parallel to AC. Considering this, we can say that PQ is parallel to RS or PQ is equal to RS. Thus, since opposites pair is equal and parallel, we can say that PQRS is a parallelogram. And in a parallelogram, we know that diagonals bisect each other. That means here PR and SQ are the diagonals and PR and SQ, they are bisecting each other. Thus, we can say that the line segment joining the midpoints of the opposite sides of the quadrilateral bisect each other. Question number 7. ABC is a triangle right angled at C. A line through the midpoint M of hypotenuse AB and parallel to BC intersects AC at D. Show that D is the midpoint of AC. Now, if you consider the triangle ACB, now what is happening? M is the midpoint, you are told, and you are told that MD is parallel to BC also. So, what does it mean? D is also the midpoint of AC by converse of midpoint theorem. Now, when MD is parallel to BC and you take AC as a transversal, you know that angle ADM or MDA will be equal to angle BCA. That means these are forming the corresponding angles. If one is 90 degrees, your BCA is 90 degrees. So, your MDA is also equal to 90 degrees using corresponding angles properties. Because MD is parallel to CB, we can use it. So, we can also say that MD is perpendicular to AC. Now comes the third part. Here let us prove the triangle ADM and CDM congruent. We have just proved that ADM is 90 degrees. So, ADM is equal to CDM equal to 90 degree, which we have just proved above. Your MD is common and AD is equal to CD because D is the midpoint. So, the triangles using SAS criteria, they are congruent. And with this we can say that MA is equal to MC by CPCT. And we already know that M is the midpoint. So, if it is the midpoint, we can say that MA is equal to half of AB. So, from equation 1 and 2, that is MA is equal to MC and MA is equal to half of AB, we can say that CM is equal to MA is equal to half of AB since all are equal. And M is the midpoint. With this, children, we finish and end with the chapter and with the exercise 8.2. I hope you must have understood all the criteria of midpoint theorem and the converse of midpoint. Please go through the concept video, please, if to clear and do this exercise properly. Very soon I am going to come up with the next chapter. Till then, see you. Goodbye. Take care.